In the last video, we learned how to use promises to create asynchronous logic that can talk to an API. And what we built was a little application that could talk to the Pokemon API, grab back some Pokemon information, and display it on the page. What I want to introduce in this video is another way to write your promise logic using async functions and the await keyword, which will make your code look a bit more readable compared to what we wrote last time. So in our promises demo here, we had the first promise that we wrote was this one that sort of after half a second either resolved or rejected based on a random number. So I'm just going to collapse that. The implementation details don't matter for reviewing. But we've got a promise here, and then we were able to chain onto that promise using .then, .catch, or .finally logic that should run. In the case of .then, it's when that promise finishes, when it resolves. In the case of .catch, it is when there's an error. And in the case of .finally, it's when the promise has either fulfilled or rejected, so it's ended up in a settled state. And we were able to use that with fetch here. So we fetched from the Pokemon API, and then we tacked on or we chained .then to get the response. And then inside of a .then, you can return another promise. So .json returned a promise that we were able to chain on another .then to, which will run when that response is converted to JSON. And then at the bottom here, we had a .catch to handle an error happening anywhere in these thens. This is perfectly fine. This expresses our logic nicely and allows us to chain on a series of asynchronous steps to our promise. But there's another way to write these. So I'll make all of this available as the starter files, but this is basically what we did in the last video with an additional little demo in here. So let me comment this out so that we can just focus on this little snippet. So I have a function in this file called wait that takes a duration, and what it does is just return a new promise that calls the resolve, so it successfully finishes after some timeout. So whatever duration we pass in here, it just sets up a timer so that when that duration has passed, the resolve function will be called. So it's purely just for demo purposes, but we've got this promise here that gets returned from wait with a 1,000 millisecond timer. So after a second, the .then is called, and it says 1 second has passed, and we can return another promise that waits 2 seconds, and then it prints out 2 more seconds have passed, and then waits 1 more second with this additional promise, and then prints out we're done. So I'm going to comment out our fetch logic, and I'm going to import that file, async await demo.js, so that we can see it running in the browser. So starting, 1 second has passed, then 2 seconds have passed, and then it's done. So this is the way that we learned last time to write our promises. And what I want to show you this time is an equivalent way to write that same logic, but the logic looks a bit more sequential when it's written out. So this is a really simple toy example, but we're going to be able to write functions that are async, which enables us to use the await keyword in that function. And await functions very much like the then here. So this is going to print out immediately when this function starts, and then it will hit this promise and await it, meaning it's going to wait until that promise either is fulfilled or rejected, and then the logic will continue running. So this won't print out immediately. It's going to wait until this promise resolves before it prints out. And then we're going to hit another promise, and we're waiting. 2 more seconds have passed. We're waiting 1 more second, and then it's done. So if I comment this out and run it, it's going to do the same thing. Starting, 1 second has passed. 2 more seconds have passed. Done. So these are both functioning the same, this chunk of logic with this main function, and this chained logic here with then and then. They're functionally doing the same thing. They just read a little bit differently. Okay, so let's dig into the syntax a little bit. I've got up at the top here 2 documentation pages for us to look at. So let me pop these both open. This page talks about async and await, and what it tells us is that as soon as you mark a function as asynchronous, when you return something, it implicitly returns a promise. So async functions always return a promise, even though here it looks like the number 1 is just being returned. You can see that if you call that function, it's returning a promise that you can chain .then and .catch onto. So it's as if, even though you said return 1 here in this async function, it's as if this is what got returned, is a promise that resolves to the number 1. And then if we scroll down a little bit more, we can see that it's telling us what await is. So await makes the function pause until that promise either settles and returns its result, or until that promise gets rejected. So inside of this asynchronous function, you can await a promise, and until this promise either resolves or rejects, this function is essentially paused and nothing else will continue running inside of that function. The other documentation page I have here is from Google, which has an example of what it looks like to run a fetch in both the promise version where we're chaining .thens and the promise version where we're using async and await. So here is something like we've done before, where you fetch, you get a response, you call one of the response methods that parses that response into a format you can use. You can chain on additional thens to sort of catch that text, do something with it, and an error catch here to grab any errors that occur. And then this other version where we have an async function, we can get the response and await it, and then we can await the response.text. And all of this is happening inside of a new structure in our code called a try-catch. So I didn't put this in my little code demo to make the code demo short, but when we're writing our async functions and we're dealing with promises, we have to make sure that we can still handle those errors that could be thrown by those promises. And the promise structure up here, where we're chaining on .then and .catch, explicitly sort of marks where the errors are caught. And so you have to do a similar thing here inside of our async functions. So we're going to use try-catch, and try-catch, the way it works is that you can specify the code that's running that could potentially generate an error inside of the try block. And then if an error is thrown inside of that block, that block stops running, and you end up down here in the catch block with that error provided to you as a parameter. So we're going to be able to put our awaits inside of here, and this catch block is going to function similarly to this .catch that we've written before inside of our chained version of working with promises. Okay, so that's enough high-level overview. I want to refactor the code we wrote to use this async await syntax. But one thing that I do want to highlight before I leave this page is that async and await, it is running on promises, so it is functionally doing the same thing. It is just a different way for us to express that syntax. And some people will find this more readable than this chained version of setting up your promises, but both are running on promises. So if you don't understand promises, async and await is not going to make any sense. Okay, so let's flip back to the code. I am going to comment out the demo, so that's no longer running. And then what I want to do is start taking this code that we wrote before and converting it to the async await syntax. So I'm going to put our new code above this commented out code and sort of copy and paste as needed to move pieces into our new syntax. So the first thing that I need to do is I need to actually create a function here that is async. So if I just create a normal function, I can call it whatever I want. Like I can call it main, or I could call it run. It doesn't matter what we call it here. This is just going to be our container for our asynchronous logic. So this is a normal function, but as soon as I tack on the async keyword before the word function, this now becomes an async function. So it returns a promise, and it allows us to use the await keyword within it. So I'm going to set up a function here, and I'm going to make sure that that function runs. And then I can start doing some of the asynchronous logic in here. So I'm going to definitely need to fetch. I'm going to go ahead and grab my fetch statement here. Actually, we'll just grab the right-hand side. So what I'm going to do is set up a variable called response that is equal to awaiting this fetch. And so await, we want to make sure that what we have on the right-hand side here is a promise, that is what fetch returns to us. So now this function is going to go ahead and run. And let me console log the response here. And we can console log at the top, fetch starting, and see something print out in our browser. So fetch starting, and then we've got the response printing out a few milliseconds later. And if I go in and change my network to slow down my network and refresh the page, we should see as soon as the page loads, fetch starting, and now the slowed version, we can see that it takes a little while for that response to come back. So we have some async logic happening here. So let me go back to online mode here. Okay, so we've got our response. This is equivalent to what we did here, where we created the promise and we chained a .then and got the response back. So I'm going to bring some of this logic up. I want to print out whether that response was okay and print out its status. So response okay is true, response status is 200. And then the next pieces that I want to bring over were we checked whether this response was not okay. And if the response is not okay, we need to throw an error to stop the rest of the chain happening here. And then what we did was also convert our response to JSON. So response.json gave us back a promise, which I can see if I'm hovering over this, it's telling me it returns a promise. So I can await this, and I can capture what is returned from that promise in a variable. So I can say JSON equals await response.json. And I'm going to keep working through this. We'll ignore the fact that an error is being thrown, and we'll add our try catch in a second. But we've now got our JSON. So this logic is going to wait for that fetch to finish before anything else prints out. This is going to wait for that response to be converted to JSON before any of the rest of this code runs. So I could grab our logic from down here. This printed out the JSON, grabbed some of the features of our data, and printed out to the console, and also put it onto the page. So if I save this and check it out in the browser, we can see Dragonite showing up, and we can see some of that information printing out here. The final piece that we need to add to finish this off is to actually properly handle the errors. Right now, we have no logic that would gracefully handle if we searched for like a gibberish Pokemon and this kicked off, our application would crash, and we're getting this error here that there was a bad API request, which is that error that we threw here to stop the rest of this logic from running. So what we want to do is take any of the logic that could potentially generate an error. So these are going to be our fetch and .json are things that involve a promise, and wrap it up in a try catch block. So we're going to take that logic, that could potentially generate an error and move it into this block. So I'm going to let's just grab all of this, move it up into our try. and then I can write catch error, and this will run if anything in here generates an error. So in a more polished application, we would do something with the error, like we would display it to the user in some way on the page and ask them to search for a different Pokemon. We'll do that when we build the React version of this in the next video. But for now, we're just going to do what we did last time of console logging that error, which is what we did down here. So let's say console.log, something went wrong, console.log error. So then if I go back to this gibberish version, what should happen is that when this error gets thrown inside of our try block, we no longer get down to this line of code. We're no longer awaiting the response.json. What happens is that we get kicked over to our catch block, which gets that error that was thrown as a parameter and allows us to do something with it. In this case, we're just printing it out. So here we go. We're no longer crashing. We are printing out that error. We can see something went wrong, and then error bad API request at run. So this is where we would gracefully handle that logic and do something like format the error message and put it onto the page so that the user knows to try something differently to avoid this error. So that's pretty much all there is to using async and await to refactor this project so that we have code that appears more synchronous in nature and is potentially a little bit more readable than the code that we had written before that chained on these functions with .then, and .catch. A couple of notes that I just want to emphasize. So await is a keyword that you specifically want to use with your promises. So you're awaiting, and then on the right-hand side, you have to put something that's a promise. Or you should put something that's a promise there. So that await keyword signals that this function should stop running until this promise resolves or rejects. You have to manually catch your errors using this try catch block when you're using await, and you cannot use await at the top level of your file. So I can't do await promise here. If I flip back to my browser, we can see unexpected reserved keyword. You can only use await inside of an async function. So you're always going to be using async and await together. So let me just clean this up, make sure everything works. Yeah, so there we go. We've got our project refactored using async and await, and in the next video, we're going to take this version and convert it into a React project.